So I'm going to demonstrate a few basic soldering techniques for different applications. I'm going to use these materials to do the samples with, and the supplies you need: a soldering iron. This is a 60-watt Weller WT-CPT unit, very common for benchtop assembly work and electronics kind of things. There's a much cheaper unit that I just recently found, and I'm going to test out and let you know more about that one later. So I'm going to use this for my soldering iron. There's a sponge here that's wet that helps for keeping the tip clean. I'm going to use 60-40 rosin core solder. It is lead and tin material. And then rosin core soldering flux. Just both of these I get from Radio Shack. That helps clean the joints, clean any oxides off of the surfaces before soldering. You need some cutters and strippers. These are just from Harbor Freight, and they work just fine. And I'm going to use this hobby vise, also from Harbor Freight. It articulates. Has this ball joint, so you can go vertical or horizontal or multiple of crazy positions. So very helpful. And if you have a smooth enough surface, this turns into a suction cup, so you can grip it onto your surface and it won't move around. But as you can see, this surface of this table is not polished enough, flat enough for that to grab on, so I just use it like that. So let's get going. To demonstrate, I'm going to demonstrate the easiest thing first. Basically, soldering wire or a component to a flat copper surface. Sometimes you can take some a green Scotch-Brite pad. I'm digging one out here like this, and you can polish the surface till you get nice, bright, shiny copper. That's really good. You can use acetone also to wipe it off. But basically, get a nice clean surface. Don't wipe off a ton of copper. Strip the wire. Use the appropriate slot in your wire strippers to strip off the end of the wire, and then twist the wires together. And then for doing this kind of a thing, it can often be helpful to use the soldering flux. Probably not a big deal for this application because it's all pretty clean materials and there is rosin in the solder. That's why I use this 32 thousandths diameter solder versus the larger, I think 60 thousandths or whatever it is, the thicker solder. This has more rosin to solder ratio, so there's a lot more rosin in here. That will help things flow together and the solder wet properly. So I'm going to zoom the camera in and show you how to solder this joint. So here you can see the soldering tip right here is slightly dull looking. It's not terribly bright and shiny, but if I wipe it across the wet sponge, see now it's nice and shiny and reflective. That's what you want the tip to look like when you're soldering. So it will, when it's clean like that, there's little oxides on the surface of the tip, it will provide a better and more efficient heating of the things that you're trying to solder together. So that's what the sponge is for. Okay, so we have our nice clean base material and our stripped solder. There are two methods you can use. I'll demonstrate both. The first method would be soldering just everything all at once. So basically I'm going to lay the copper wire onto the copper strip, the copper pad that I'm soldering to. I'm going to clean the tip. Get this so you can see it all. I'm going to clean the tip by wiping it on the wet sponge, then put a little bit of solder on the tip so it's nice, fresh, clean solder. Then I'm going to apply the soldering iron tip directly to the copper pad. Apply a little bit of solder to the iron to let it kind of help wick into the actual copper pad. I'm doing this longer than I normally would just to demonstrate. And basically you can see that's already soldered, kind of. It's stuck on there. I would do more than that for a real joint, but that works. It really doesn't take a whole lot, and rather than you want to make sure that the joint gets hot enough. So basically, to do that, you want good connection on this tip. There's a flat right there. It's not a cone. It doesn't go to a point. It comes kind of to a chisel point. Put that flat surface directly on the surface of the copper. Roll it till it's flat. That'll help transfer the heat from the soldering tip to the copper pad as fast as possible, which is important so you don't melt the components that you're working with. So I'm just going to finish this joint. A little bit of solder on the tip to help things flow. Apply it to both parts. Really, you want to be touching both parts with the soldering tip, and then touch the solder to the hot parts, not to the soldering iron tip. The idea is that you want the parts hot enough for the solder to melt. Otherwise, you risk getting a cold joint if you're just always applying solder to the tip itself. Obviously, that will be hot enough to melt, and then it'll flow onto the base material. But if you do that, you risk. I'm going to see if I can do this or not. I'm actually going to spin this around because this area of the copper pad is heating up enough. I'm going to do this cold area right here that's kind of a little bit dirty, and I'm going to try to do a cold joint. It's hard once you know how to do good hot joints. I'm going to only apply the solder to the actual iron, and I'm not going to stay on the pad long enough to really let it soak in much. There. So yes, I got solder to stick to the base material. Is it a good joint? No, because the tip is, I'm going to use these pliers. See how the solder is beaded up? Its base of it did stick enough, but it's so beaded up and mounted high and the edges aren't blended in. What this should look like is, watch, boom. There, you saw it soak in and kind of blend in and not become this humped mound, but it's more of a pool that is blended into its surroundings. You could even spread it out a little bit further. And you can see that's called wetting with an H, W-H-E-T, wetting. It actually, the solder is actually soaking into the materials and making everything glue together very solidly versus sort of like scabbing it together. So that's one method, just directly heating everything all at once. Another method, I'm going to cut this wire fresh and strip the end again. Another method is tinning both parts first. That can be really handy if you're kind of juggling multiple parts, which even this application, see I have the wire bent over. I can't use, I need more hands, more fingers than I have. So in other words, I would have to hold the wire down, then hold the solder in, which you could do. You could get creative with all your fingers. You know, you need to apply the soldering iron, the solder, and the wire. So technically, yeah, I can get my fingers to manipulate enough to do that. But it's way easier if I prepare all the surfaces first. So here, I'm going to prepare this by what's called tinning it, which basically just means getting solder on it, pre-soldering the copper. So now there's a solder coating on that wire. And now I'm going to pre-tin the copper pad. Same deal, get a little bit of solder on the tip, then heat the part, wait for it to heat up, then add some solder to the actual part that's hot, not necessarily only to the tip of the soldering iron. So now I have a soldering, a little pool of solder there, and I have solder here. So it's not going to take much now just to heat up both and let the solders flow together into one mass. So now I apply the heat directly to the parts, let it all heat up. I moved it so now I'm touching both parts with the soldering iron. I let it heat up more, and then I take the tip away, let it cool down, and I've got another solidly soldered joint. So two methods of soldering.